Hi, Algebra. Today, we are going to just briefly talk about the discriminant. It is a formula that you are provided with, okay, on the algebra test. But what does it really mean? We're not going to focus a lot on it, but I did want to introduce it to you. You're going to talk a lot more about it when you get into Algebra 2. The main focus is understanding how to solve quadratic equations by factoring, which we did, and completing the square. This is a last case scenario, okay? You're simply plugging in and you evaluate to find how many solutions that you can have. Because remember, with a parabola, when it crosses the x-axis, y is 0. Okay, but the values, or the zeros are what they call them, are where they cross for the x values, okay? So when we did this, we realized, so if you notice here, by using this formula, we didn't do factoring, we didn't do complete the square, but they used the exact same formula. And if you notice, look at how much more it takes, okay, compared to these two. That's why I don't want to focus on this, but I did want to introduce you. It is a formula. Many times they're going to be yucky numbers when you use it. But the beauty of the discriminant is when we use what's in the Radicand sign, we can actually determine how many solutions it has. So if your number is greater than 0 or less than 0, and what you learned yesterday, it depends on how many solutions you have. Okay, and the other way is by graphing, and right here. Okay, tomorrow I am going to meet with you, and we're going to look at your calculator to determine how we can use it to find solutions to a quadratic. Okay, let's look at, let's go ahead. I'll put it in here. The discriminant. This is why I don't want to do too much with it. Because you are given, it is negative b plus or minus the square root of b squared minus 4ac. And a lot of you took notes. If you took notes yesterday, don't even bother putting that in there. Just remember, this is a last choice for solving. It is yucky, it is long, and we don't need it, especially when we can factor, okay? Just so you have it. Now what I want to do today is talk about, you have a front and a back. We're going to make a pocket today. How do we use quadratic? What's its importance? So actually, let me sharpen my pencil. I should use that. No, I'll use a pencil. Okay. So, for example, we have a quadratic that is talking about profit. Many times in business, or if you owned your own business, you want to make the most money possible. But there's a lot of things that can affect what you charge and how much profit you make, right? If your price is too high, you're not going to make that much profit because people ain't going to buy it, okay? If you price it too low, you're not going to make quite as much money. So there's this fine line of what is that perfect price. Okay, so we're going to talk about Sarah. She is making some iPhone cases. Okay, all right, maybe if you want to talk about a different, make a company name, whatever you want to do. But here is a quadratic equation that talks about her profit, which is graphically represented here. Okay, so we talk about the P of X, the function notation, which means Y, which is her profit. Okay, so remember that when we do function notation, it means that the function of x, okay, which means the price that she is going to charge. So what should she charge for maximum profit? So this is what the charge per phone is my x, okay, and this is going to be our profit. Because remember, the profit depends on the charge per phone. Sorry, there's an E right there. And so if you look at the graph, the maximum profit is actually going to be our vertex. So the vertex are the maximum or the minimum, right? So this is her maximum profit that she can make. And so they want to know, what should she charge to maximize her profit? If you notice, they've already given me my vertex. And so this is the profit. We know it's maximum because graphically I can see that. But this is what she should charge. And so how does she find, what should she charge to maximize her profit? Is that our vertex? Yeah. So the vertex, and if you remember, I'm going to pull it back. Let's go back to Okay. Is it the axis of symmetry, or is it my y? It's going to be, algebraically, I'm looking for my x. So always remember that algebraically, we are looking for when x is equal to negative b divided by 2a. So if I put in, so my negative b would be a negative 1920 divided by 2 times negative 20 would give me a negative 40. And if you do the division, guess what you're going to get? You are going to get 48. Because a negative divided by a negative is always going to be positive. Okay? All right, so what will her maximum profit be? And we already talked about that. We know that it's going to be right here. So it's going to be 36,980. Okay? How did I find that out algebraically? Well, if I found my x, what did we say we had to do? That's right. We're going to plug in my x. I'm going to use the formula negative 20 times 48 squared plus 1920 times 48 minus 9100. So if I were not given this graph, this is how I would do it algebraically. But obviously, it's pretty easy when it's already done this way. And we know that the maximum profit is going to be 36,980. Okay? Now, if she charges 0, what will her profit be? Well, if I charge $0, think about that. You're not going to sell any, but you've already invested. You've already had to buy supplies. You've had a startup cost. And so that's why that this function here shows us that the actual is going to, they've given it the y-intercept, not my solutions, but my y-intercept. So I'm actually going to have a loss of negative $9,100. Now, how do you know that, what will we do? Well, look at our equation. If x is 0, that's right, I'm just going to substitute 0 into my quadratic equation. And the y-intercept is right here. Okay, so I'm going to go ahead and model that. So it'd be negative 20 times 0 squared plus 1920 times 0 minus 9100. Okay, now what is her profit if she charges $60? Well, that's right. We're just going to put it into our equation. So we know that the function of x is going to be equal to negative 20 times 60 squared plus 1,920 times 60 minus 9,100. And remember, we're subtracting that because that's what our startup cost was. Okay? I'll let you put that into the graph, put that into the calculator, sorry, and find the solution there. So how would we determine if we sold, or the cost was $110 is what we charged. Is this true? Would in other words, if I'm selling 110, that's more than my maximum profit. Why am I going to take a $39,900 loss? I want you to think about that. Do you think it's true? Why would this happen? If I charge $110, that's going to be about out of here. And so all you had to do was what? Take your quadratic formula, plug in 110, and you would actually get negative 39,900. But why? Why do you think that is? So talk to the person next to you, and I want you to think about that. Okay. The next one that we have is a parabola for a business, just basically on cost. As you get into Algebra 2, you're going to get a lot deeper into this, but honestly, I love the real life application because it kind of explains why we use it. When you have a cost, the function of a form parabola, it opens up. The larger a business becomes, guess what? The more expenses that it has. So the scenario that we have is Jack started a business making and selling fashionable hats. This is the graph of the function of the cost of X, okay? Where the function, this is my Y, is the cost, this is my cost, of producing X number of hats. So this is my number of hats. Oh, sorry. Use the function in its graph to answer the questions below. So interpret the meaning of the ordered pair 1,950. What does this mean? Well, if I sell how many hats? 1,000 hats. My operating cost will be $9,500. Okay? If you know that X represents the number of hats he produces, select the appropriate domain. So what is my domain? Domain is my X values. Okay? Can I make negative hats? No. Okay? What would my domain be? That's right. Be greater than or equal to 0. Okay? Because even though my cost can still increase, I can make never-ending hats, right? Now, I may have limitations of the company. It depends on my operating, what facility I have. Maybe there is a limit. Maybe I can't make more than 1,000, but they didn't give that to us, okay? So how much did it cost him to start this business? Well, if you make 0 hats, and if you notice, it's a little bit different than the quadratic that we had on the other side. If you read this, it looks like our cost is going to be what? Well, if you have 5,000, this would be 4,000, 3, 2, 1. I would say be about $1,500. So if I don't sell any hats, it is automatically going to be 1,500. Does the vertex have any significance here? What do you think? No, it doesn't. I don't think it does. Okay? Because really, you can't make a negative hat, can you? And so as we talk about, this is going to be our next unit, there are times on a parabola that really you're only operating in the first quadrant, okay? And I would say no significance. Okay? All right. So I want you, let's go ahead and make a pocket. How many minutes am I at? 13 minutes. Okay. Trying to hurry, guys. Okay. So when you make a pocket, open it up. Turn the page, fold it down, bring it back, and then you glue it on the bottom and the side there. And what I want you to do is insert this. If you don't like it, then you know what? Find another way to make a pocket or stick it in your book. And you're going to put it right there. And real world examples of quadratics. All right, you have a front and back. I want you, this is a little bit more practice on real world examples for you to do individually. Like I said, I'll be in the classroom, so if you have any questions, I'll be happy to answer them.